My name is Marc Kegelaers. Surname is impossible to pronounce, so Marc is what I am usually called. I'm wearing two hats today. I'm the CEO of Unifly. We're a software company that makes UTM software, and what that's all about we'll look at in the presentation. But I'm also the Vice President of the Global UTM Association. That's a worldwide association of about 70 companies right now that all have to do something with UTM. If there's any questions about that, please ask me afterwards. So, we're a European company, and in Europe, the first drones started to appear in the airspace around 2012. Firstly, was only a few, and at that stage, the air navigation service providers didn't really care about all those drones, but the number of drones has been increasing steadily. Even so much so that it is expected that the drone industry, the industry that we are all active in, will become very important in the world economy. And one of the more interesting reports in that respect was written by PwC, Clarity from Above. It's a report that can be downloaded from the internet free of charge. But that report forecasts that the drone and drone services industry in the world will be valued at something like $127.3 billion US per annum as of 2025. So that's a big number. So there's some money to be had there. But this drone market, this drone industry will not happen. It will not. Unless we can figure out a way of integrating that drone traffic in the national airspace in a safe manner. And that is the pain that all ANSPs and all CAAs in the world are now facing. Manned aviation is a very highly regulated environment. It's also a very safe environment. Now, all of a sudden, you have these large amounts of drones appearing in the airspace, and the challenge is now, how can we maintain the level of safety that we have in manned aviation, where you have all of these new entrants in the airspace? And there are some problems if you want to tackle that problem. Let's look at the differences between manned and unmanned aviation. In a manned aviation, you have very, very strict standards when it comes to making, producing, running aircraft. In the unmanned world, no standards yet. I have not seen any clear specification and specs and type rating definitions of what a drone needs to be. In the manned aviation, you have very formal procedures of where you can fly, how you can fly, how high you can fly, what procedures you need to follow. Not so in the drone world. In the drone world, everyone does approximately what he wants to do. Now, we're talking about creation of procedures. There are connoissances are being written, but they're not there yet. In the world of manned aviation, you have extensive training. In the world of unmanned aviation, you have from 0 to about 7, 8, 10 days of training, and that's a problem. I used to run, for 10 years, I used to run a flight school. We were training commercial pilots, and typically you have a commercial pilot in your hands for 1.5 to 2 years, and that gives you the opportunity to brainwash young kids that safety is of utmost importance, and you have to adhere to procedures, and there are rules and regulations for a good reason. In the unmanned aviation, you don't have the time to brainwash the kids. You have, 7, 8, 10 days of training, most of which is spent on learning to fly the aircraft, and then 2 or 3 days on regulations. But most of the drone users will see regulations as a nuisance, not something that is of value for the safety. So that's a problem. In the manned aviation, you have very comprehensive ATC. ATC sees all of the aircraft. Well, not so in unmanned aviation. So how can you manage those drones? So it's not possible to take an air traffic management system of manned aviation and just implement it for unmanned aviation. So there's a problem. even bigger problems come when you think about numbers. I'm not sure if you realize, but the total number of aircraft in the world is estimated to be about 360,000, of which only 23,000 are commercial aircraft. Some companies say 25,000. Of those 25,000, you have about 10,000 in the air at all times. So the entire ATM industry and the entire ATM infrastructure has been created to manage simultaneously about 10,000 aircraft at any moment in time. With the unmanned aviation, and these are old numbers, it is expected that by 2025 there will be about 4 million drones flying in Europe alone, and it's estimated that today worldwide about 7 million drones have been sold. Those are staggering numbers. Those numbers have surprised all of the ANSPs and the CEAs in the world, because what they've seen is that they wanted to use their existing procedures to allow drones to fly and approve flight plans. Now, with the standard procedures that they have, that's not going to work because the numbers are staggering. In the world of manned aviation, if a Boeing passes by, that's a big money-generating machine it is flying by, so the organization that runs that aircraft has the resources and the time to plan that flight extensively. You can spend some times and some hours in planning that flight. In the drone world, well, if you have a drone taking some pictures of a bridge, the value of that is not very big. So planning that flight, you will not want to spend hours and hours in planning that flight. You need to have something that's much more efficient. And last but not least, there's new entrants into the market, in the sense that because drones are flying so low, there are all of a sudden other authorities than aviation authorities that want to have a say in where should drones fly or not fly. Police forces want to know if the drone it is flying by, who is that? Is he a legal one? Is that flight plan hasn't been approved? And maybe the police force want to be able to block off pieces of airspace. So there's another conundrum there that needs to be resolved. Okay. I wouldn't be telling you this if we didn't have a solution for that. So we've created a UTM solution to serve all of the stakeholders in this industry. And who are the stakeholders? First of all, manned aviation. And one of the first things that we did when we were developing our product is actually create a user interface so that our UTM solution would seamlessly integrate into the ATM world. On the left side, you will have what we call end users, drone operators, companies that operate drones, end users that want to use drones, and maybe other types of service providers. And on the right hand, the stakeholders are typically the authorities, airspace managers, air navigation service providers, but also police forces and local authorities. What we've created basically is what we tend to call our Unifly core. It's a big database application where we use cloud technology. It's an application that was built to be able to process massive amounts of information in real time to support real-time mission-critical applications. Around that, we have an API, so all of the things that we do, we talk to our own core through an API, and that API can be made available for third parties. And we have also built a number of UTM clients so that we have pieces of software that we can put into a drone, into trackers, or into ground control stations. So that's the architecture. And with that architecture, we implement comprehensive UTM solutions, typically on a national scale. Now, implementing a UTM system is typically a phased approach. We've not seen a country that says, do a full-blown UTM and I need to have it tomorrow. No, typically it's a phased approach. First thing that needs to be done is you have to reach out to the drone community. 85% or even more of the drone users are end users. People that go into a shop, they buy and they want to fly. How do they know where it's legal to fly? How do they know where they should not be flying? we've heard a lot of words about trying to educate people and giving them leaflets where they should or should not fly. All of that doesn't really work, because a young kid, 15, 16-year-old, that goes into a shop, has a drone, he's not going to read a leaflet. He doesn't want to have an extra course with. What you can provide him with is an app and or websites that give him aviation information in such a way that he will want to use it and he understands it. That's typically what the first phase of implementing UTM system needs to be. Provide good information, exact information to a drone community that they will understand and that they will be willing to use. Typically, a next phase is you want to manage access to airspace, and specifically sensitive airspace. What you want to do is, so in the first phase, you've created maps where you can show where you can fly or not fly. But in the second phase, you really want to create that, a very dynamic environment. You want to be able to publish no-fly zones. Typically, no-fly zones are things that could be decided now in real time, because there's been an accident. We don't want to have 20 drones taking pictures of people lying on the street. So publishing, creating no-fly zone. We need to have an automated and as user-friendly as possible flight authorization process. That's typically where this is implemented. We want to have a tool of communicating with the pilot, not by voice communication, because the sheer amount of drones, you will not be able to communicate by voice, but you typically want to be able to communicate with text. And you also want to manage the database. So this is typically where we see that the need comes in, or the requirement comes in, of creating a drone and user database. Okay. Once you've done that, you want to go to the last phase and then do real-time flight status monitoring and tracking. So ideally you would want to visualize manned and unmanned information in the real time. You would really would like to be able to do conflict resolution. So those are the phases that we see where ANSPs and CEAs are wanting to use or implement UTM. So we've created a class-based infrastructure that will connect to a bunch of databases. Typically, we are connected to the world of manned aviation, so we can read in no times. We have the airspace data of just about the world, so we know where the CTRs is, the TMAs, and so on and so forth. We've built a technology where we can take a national regulation or even a regional regulation and put that in a database format, so we can start to validate, is a drone supposed to be there, yes or no? And we can use any GIS data that you may want to have to define if someone needs to be somewhere, yes or no. On the left side, we've built a number of user interfaces, being apps and websites, that will provide information and real-time information, updated information to end users. And on the right side, we have a number of functions which we can group very much the way that we want. But typically we see one set of users which would be an administrator of the regulators. They would want to put in, they want to use the system as a drone registration and user registration format. Special authorizations that they want to create is in there as well. And then we typically have the supervisors in the ANSPs. They will want to do dynamic airspace management, flight tracking, alerting, deconflicting, and so on and so forth. So that's the environment that we've created and which exists today. Again, some of the core functionalities, what authorities can use the system for: reach out to your community, provide easy access to readable information, provide a real-time no-drone zones map, manage the access to the airspace, so publish no-fly zones in real time, which is quite unique. So the moment that you hit the button, within a second, everyone in the system knows about it. Automate instantaneous flight approvals, and so on and so forth. Manage your databases, both the pilots and drones, but also flight logbooks are in there, flight authorizations are in there. And then monitor traffic in real time, So, and that is really real-time flight status and location. And what is unique is multiple level of authorities. We do see a world where you have a national authority that wants to manage the access to the airspace. You may have a regional authority that wants to manage the airspace, but even local towns or even harbors that say, well, I really want to have some say in who's flying over my airspace. And then core functionalities for UAS operators, easy to use mobile and web applications, and has been designed in such a way that you do not really need to know anything about aviation to use our software, which makes it quite unique. Complete and accurate national and local rules and readable no-fly zone maps. You don't really have to be a specialist to be able to understand it. It also provides tools to plan and validate your entire operations. So you can manage your own pilot database, your own drone database. You can plan flights, validate a flight if it can happen, yeah or no, deconflict it with other flight plans, and then manage the flight authorization requests. And then keep track of your flights. So within these applications as well, you can actually monitor where your flights are. And what we've recently added is that we have the information of other drone users and other manned aviation. Well, we can put that in the map as well. So that when you're flying a drone somewhere and all of a sudden there's someone else flying in your vicinity, you are aware of it. So, and that's real time. Some examples of dynamic airspace info, those are real websites. So those are typical national authorities that are using our technology to provide information to their community. Some examples, authorization request and approval. One of the problems that exist is very often you have a piece of land where you have to have multiple approvals to fly there, one from the aviation authorities, one maybe of the local police force, and maybe one of the owner of the land. Well, within the application we can have as many layers of approvals that we want. And for the user it's just hitting a button, and then each of the authorities have a screen like on the right hand where they get the detail of the flight and they simply say yay or nay, and that information gets sent to the users in real time. Flight tracking, conflict alerting, replay. And that really was done in cooperation with one of the ANSPs in Europe. They wanted to have a screen which mimics the screen of manned aviation, because that's what the air traffic controller knows. So that screen really looks like an ATC screen, but guess what? The drones are appearing on that as well. So you could actually have visualization of where the drones are versus where the manned aviation are. Now within that application we do deconflicting, so if a drone gets too close to other drones or to manned aviation, we'll generate alarms. And within this part of the application we can actually do replays. So we can ask ourselves, where was the traffic yesterday between 2 and 4, and were there any airspace infringements that we can do with this part of the software. So we have, despite the fact that we are a young company, we already have quite a bit of references. 4 ANSPs so far in Europe have chosen our product as a platform to build their national UTM system. And the very first one that we won was Germany, the Deutsche Flugsicherung. And that's probably one of the most difficult countries to work in, because they have one ANSP and they have 18 CAAs, so 18 different sets of rules. It's a very densely populated area with a very complex legislation. We have Denmark with Naviair, we had Austria with Austro Control, and then Belgium with Belgium Control. Other references, we are doing a major UAM development in the APAC region. I'm not allowed to say yet who we are doing it for, but that probably will be announced about 2 months from now. Africa, we have a reference in Africa. UNICEF have implemented the first UTM in Africa in Malawi. The base of that is our software, and we work there very closely together with UE Avionics, where the tracking devices on the drones are from UE Avionics, and so we can actually track drones going quite far beyond visual line of sight. And just last week we were selected in the US. In the US there's several programs happening. There's the UAS Integration Pilot Program is a research program where 10 projects were chosen to get local authorities involved in UTM. We are, as a European company, we have been chosen to participate into those projects. Other references. In Europe, there are quite a number of research projects going on to create an environment in Europe where drones can be used happily. The Quarters project is a project where the concept of operation of unmanned systems is being defined at the European level, so that if a company wants to buy drone-related services in Italy or in Denmark or in Spain, that the concept of operations is the same. There we are working with companies like Eurocontrol, INAF, which is the CA in Italy, DGAC, which is France, NATSE, which is the UK, DFS, obviously one of our customers, and other research organizations. SkyOpen is a very interesting project that is done in Switzerland. Mountainous areas where almost by definition, when the drone goes around the corner of the mountain, you don't see them anymore, it's BV loss. But you also do not have any communication anymore, so you have to do the communication with the drone via satellite. That's why we have Viasat in that network. Podium is a very, very ambitious demonstration project where we are working with Eurocontrol, Airbus, Delair, major manufacturer, DSNR France, Drone Paris Region. That's about 180 drone flights, most of them being beyond visual line of sight. They will operate from 4 different airports in 3 different countries, and all managed through our software. And there will be a multitude of tracking technologies that we will use and integrate. CLASS is another very interesting one. That's a project where we want to do research of how do you deal with non-cooperative drones. In our database, we normally have the cooperative drones, but there are other drones flying about as well. So you want to detect them and see and compare that to the database. In the CLASS project, we have a partner called Availent. Availent is a company that makes drone detection radars, quite good ones. They've now been bought by Thales. And typically what will happen there, that radar will detect everything that is flying in the airspace. We have in our database the cooperative drones. If you do A minus B, you have C, and C is the culprits, the guys that you really need to go after. And then CCOPS is a project that deals with data security and encryption, the communication between the central management system and the drone. You don't really want to have hackers to get into that communication, so that's the research where we are looking at that. We are involved in 2 more research projects in Europe, which I cannot mention yet, because the contracts with the European Commission haven't been signed just yet. Now, why is Europe spending a lot of money on research? Because there's a vision in Europe that says that drones will be a significant part, will drive a significant part of the economy in Europe. There's a lot of employment that sits behind it. There's a lot of added value that sits behind it. And they want to create an environment where drones can be used safely. So safety really on top of mind. Drones will have to be operated quite automated. And the initial phases need to be up and running by 2019, which is not that far away. Okay. There are a number of function sets that have been defined and timings behind it. So the phases that UTM needs to be implemented is U1, 2, 3, 4. U1 deals with e-registration, e-identification, and geofencing. U2, management of the drone operations, which is also flight planning, flight approval, tracking, dynamic airspace information, and procedural interfaces with air traffic control. U3 is complex operations in dense area, capacity management, and so on and so forth. And U4 is fully automated, interactive drones. There are some timings in it. We currently support U1, 2, and a good chunk of U3, where U3, from a European point of view, does not need to be implemented until 2025. So. Okay. So in summary, what we've created is a bunch of software technology which is in existence today, is ready to be deployed, is being deployed already in 4 different countries. It's being used by multiple ANSPs in a multi-language environment. That's also another thing. Because of living in Europe, you have to make sure that your software supports multiple languages. It serves all of the stakeholders. It's an open and API-centric architecture. So we don't think that we will be developing all the software that you could ever think about. So that's why we created this API, so that system houses and other organizations can use our platform to create comprehensive UTM solutions. And it's very much in line with international standards. So Uspace is a very big thing. Obviously, it drives a lot of our efforts. But also we are in compliance with the GUTMA architecture. GUTMA is the Global UTM Association. They've issued an architectural document. It's a living document. We very much focus on that so that we do adhere to international standards. Two words of our company. The company was started only in 2015, so we are quite young. But the idea of wanting to create a traffic management system for drones was already started in 2012. So we're already working for 6 years on this product. Founders of the company are air traffic controllers and pilots, and they very rapidly got in contact with a research organization that does a lot of stuff with drones. So they started to work on a prototype of a UTM system. It wasn't called UTM at that time, a drone traffic management system. And one of the first things that we did is create this interface to manned aviation, which we did using the SWIM standard, System for Worldwide Information Management. That's a set of protocols that is used within the ATM world for exchanging information between ATM systems. So we are fully compliant with that standard. And actually, we participated in a contest in 2014. That's a European contest where companies from all over the world can present their SWIM-compliant software and get points. That year, there were 81 contestants. We didn't win. We came in second. But the number one was Airbus. So, we're proud to have lost against Airbus. So, at that moment in 2014, we realized we had created a technology that could be quite significant, and we decided to create a company in 2015. In 2016, we completed 2 rounds of financing for in total about $7.4 million US. Last year, we opened offices in the US and in Denmark. And this year we'll be doing a next round of financing. We have been on the radar screen for quite a while in various publications. We've won multiple awards. I'm not going into detail on that. And last but not least, we seek to be a global company, a market leader in this UTM space. And that's why we participate in a lot of international and national working groups and standard definition organizations. At the global level, we are a member of CANSO, ATCA, JARUS, AUSI, and the Global UTM Association. In Europe, UVS, in fact, that's how Sean and we met. Sean saw me give a presentation last December in March and said, you really need to come to South Africa. So here I am. CESAR is the research organization in Europe. EuroCAE is a European standardization body, and that standardization body defines the technical standards that need to be used in the aviation world in Europe. And obviously EASA is the European Aviation Safety Agency. That's the organization that defines the regulation for all of Europe. We participate in many of the working groups about UTM and Uspace. And then we have a number of local organizations. The orange thing is VOCA, is the Chamber of Commerce of Antwerp. I'm a board member of that organization as well.